Previously, you learned the concept of parallelograms. Now, you will explore another type of quadrilateral, and that is the beauty of trapezoids. Trapezoid is defined as a quadrilateral with exactly one pair of parallel sides. Before we dive right into our study of trapezoid, it will be necessary to learn the names of different parts of these quadrilaterals. And in order to be specific about its sides and angles, all trapezoids have two main parts, the base and the legs. The base. The opposite sides of a trapezoid that are parallel to each other are called the bases. Legs. The remaining sides of the trapezoid which intersect at some point, if extended, are called the legs of the trapezoid. Base angles. Two consecutive angles whose common side is the base are called the base angles of a trapezoid. And as you can see in the figure, there are two pairs of base angle. So you have here the bases, the legs, and the base angles. The name of this trapezoid is trapezoid LADY. Same with parallelogram or any polygon, we tend to name any polygon from one vertex and do it in a consecutive manner. The sides of the trapezoids are segment AL, segment AD, segment LY, segment DY. And the angles are angle L, angle A, angle D, angle Y. And its vertices are L, point A, point D, point Y. There are two diagonals in this trapezoid. You have here segment LB and segment AY. And there are two pairs of base angles. Angle L and angle A from the segment LA, which is another base. Angle D and angle Y from the base or from the segment DY. There are two types of trapezoid, the isosceles trapezoid and the non-isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. As you can see in this figure, the segment AD and segment BC are the legs of these trapezoids and they are equal in measure. While non-isosceles trapezoid is a trapezoid with no congruent legs. This figure, trapezoid ABCD, is an isosceles trapezoid, while trapezoid EFGH is a non-isosceles trapezoid. Now let us look at the properties of the trapezoid. For our first property, it states if a quadrilateral is an isosceles trapezoid, then each pair of these base angles are congruent. Property number 2, it states if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. Property number 1 and 2, in this figure, as you can see, you have here a trapezoid. And this is an isosceles trapezoid because, as you can see, it has two pairs of base angle, one with the color green and one with the color blue. The third and last property for trapezoid states that a trapezoid is isosceles if and only if its diagonals are congruent. Figure you have this trapezoid and the pink diagonals or the colored pink segments represents the diagonals and it must be congruent. Some examples about trapezoids. Example number 1. Consider the isosceles trapezoid LIFE. For letter A, if the measure of angle F is equals to 119 degrees, we need to determine the measure of angle E. And for letter B, if segment EX is equal to 15.1 centimeters and segment IX is equal to 12.4 centimeters, determine segment LF. So let's start with letter A. Since angle E and angle F are what you call the base angles, using property 1, angle E is congruent to angle F. So since they are congruent, hence measure of angle E is congruent to the measure of angle F. Measure of angle E is equal to measure of angle F. Since angle F is equals to 119 degrees and they are congruent to angle E, the measure of angle E is equals to 119 degrees. Therefore, the measure of angle E is equals to 119 degrees. Continue example number 1, letter B. Since trapezoid LIFE is isosceles by property 3, the diagonals for the segment EI is congruent to segment LF. Hence, segment LF is congruent to segment IE. Segment LF is equals to segment IE. Segment LF is just equal to segment EX plus IX. And segment EX is equals to 15.1 centimeters while segment IX is equals to 12.4 centimeters. We can add them and get the measure of the segment IE. And with that, we have 27.5 centimeters. And since segment IE and segment LF are just congruent or equal in measure, we could say that the segment LF is equal to 27.5 centimeters. Therefore, segment LF is equals to 27.5 centimeters. Example number 2. Find the value of x so the trapezoid ABCD is isosceles. So this is your figure for that. So for a solution, using property 2, thus we could say that the measure of angle B and angle C are congruent. Hence, measure of angle B and angle C is equal to each other. So you could say that the 2x plus 4 degrees is equal to 54 minus 3x degrees. By transposing the necessary terms we need to transpose 3x on the other side of the equation. That makes it a positive 3x. And we need to transpose 4 on the other side of the equation. That makes it negative 4. 2x plus 3x, that's 5x. While 54 minus 4, that's 50. To cancel out 5, which is beside x, we need to divide both sides by 5. And 5x divided by 5, we can cancel out 5, which give us x. And 50 divided by 5 is 10. So therefore, x is equal to 10. Now, as you can see in the figure, you have here the word median, the one with colored green. The median is another part of a trapezoid, and it is a segment that connects the midpoints of the legs of the trapezoid. It is often called as the mid-segment of the trapezoid. Median and mid-segment are just the same. consider trapezoid LADY. The median here is segment EF, which is shown in colored green. The mid-segment or the median is just equal to 1/2 of the sum of the two bases. Let's have an example in finding the median. Solve for the length of the median of each trapezoid. So for our first example, we have here this figure. Now applying the trapezoid median theorem, where it states the median is just equal to 1/2 of the sum of the bases. So here your base measures 8 and 16x, while the median measures 12x. So applying this median theorem, median is equals to 1/2 times base sub 1 plus base sub 2. So you have here 12x equals 1/2 times quantity 8 plus 16x. By multiplying it with 1/2, you can have there that 1/2 of 8 is 4 and 1/2 of 16x is 8x. So 12x equals 4 plus 8x. And as we transpose the necessary terms we need to transpose, we can transpose 8x on the other side of the equation. That gives us 12x minus 8x equals 4. 12x minus 8x, that's 4x equals 4. And as we cancel out 4 beside x, we can have x equals 1. Thus, the length of the median is 12x. And since x is 1, so 12 times 1, that gives us 12. Therefore, the median is 12 units. Second example, for solving the length of the median of this trapezoid, you have this figure. In this figure, your median is 4x, and the base are x squared plus 2 and x squared plus 6. So applying the trapezoid median theorem, median is equals to 1/2 of the sum of the bases. So you have here 4x equals 1/2 times x squared plus 2 plus x squared plus 6. If we can still simplify what's inside the parentheses or grouping symbol, that would be 2x squared plus 8. Then we can get 1/2 of 2x squared, that's x squared, and 1/2 of 8, that's 4. So 4x equals x squared plus 4. Simplifying this, you can arrange it in this term, or just doing this one. So as you can see, you have here a quadratic equation. So in order to get the value of x, we can apply the zero factor theorem. So that would be quantity x minus 2 times quantity x minus 2 for the factors of x squared minus 4x plus 4. Then equate it with 0. Since they're just the same, you have here x minus 2 equals 0. X would be 2. Thus, the length of the median is 4x. And since x is 2, 4 times 2, that's 8. Therefore, the median is 8 units. In the world of trapezoid, you can also hear the word trapezium. Trapezium. Trapezium and trapezoid are commonly taken as the same, but definitely they are not the same. Trapezium is what is often called the general quadrilateral, and a trapezium is a quadrilateral with no pairs of parallel sides, and it makes it different from trapezoid, because when you say trapezoid, it is a quadrilateral with exactly one pair of parallel sides.